All right, what we're going to be looking at is solving a system of equations graphically, where your system includes one linear equation and one quadratic equation. So the first thing we're going to do is we need to solve each of the equations for y. That'll put them into a form where we can graph our equations easily. The next thing is we're going to graph our linear equation using your slope and your y-intercept, graphing your y-intercept first and then your slope with rise over run. Then we're going to graph the quadratic equation using this form right here. And then we are going to find the solution, which is where we have our points of intersection for the two graphs. Now there are three different ways that our graphs can be oriented. We could have a situation where the graphs, the line and the parabola, only intersect at one place. An example of that might be a parabola that looks like this and a line that intersects like this. Okay, so that would be one form of a situation where you would have one solution. Or you may have a parabola and then have the line be tangent to that parabola at a particular point. So you would have one solution there as well. You could also have a situation where you have the line intersect the parabola in two places. That would give you two solutions. And then you could also possibly have no solution, which means these two graphs do not intersect each other at all, and they never will. So those are three different ways we can have our graphs oriented. One solution, two solutions, or no solution at all because they do not intersect each other. All right, so let's practice graphing our parabolas for a little bit. You should be familiar with graphing your lines. We're just going to concentrate on the parabolas for a second. Now, looking at the vertex form that we have right here, the h value determines your horizontal shift, left or right. If it's a plus h, that would be a shift to the left. If it is a minus h, it would be a shift to the right. And then the k value is your vertical shift, up or down. Plus k would be a shift up, minus k would be a shift down. A represents your vertical stretch or compression. If your A value is larger than 1, it's a vertical stretch. If your A value is between 0 and 1, it is a vertical compression. And if your A value is negative, it is a reflection over the x-axis, which means it would open down. So if you have a positive here, like we do on this first example, that's going to be a parabola that opens up because you have a positive x squared. If there was a negative in front of here, it would be a parabola that opens down because you'd have a negative x squared. All right, so the transformation for the 2 then, because it's a minus, that shifts the graph 2 units to the right. And then this tells us to shift the graph 3 units up. So moving 2 units to the right and then 3 units up will put us right here. Now that point represents the vertex of our parabola. And since we know that the parabola opens up, it's going to look like this. Now we need some more points around here to be able to get a better idea or a more accurate graph of our parabola. So since we have used the x value of 2, I do not need to use that x value anymore. But I want to find out where is the graph when x is 1 or when x is 0. Where's the parabola point? Where are the parabola points going to be? So let's take an x value of 1 and plug it in. All right, so if we plug 1 into our function right here, Well, 1 minus 2 is negative 1. When you square negative 1, you get a positive 1. Plus 3 is 4. So 1, 4 has to be on our graph, so we can put a point right here. Now, because a parabola is symmetrical, there's a line of symmetry. Points that are on one side of the graph will also have to be on the same place on the other side of it. So, since our graph of our parabola goes through 1, 4, that means 3, 4 also has to be on the parabola because this is our vertex. So the graph is going to go like this. Okay. All right, so 3 points is better, but it's still not really enough. Let's get at least 2 more points. We want to have a total of about 5 points, ideally. All right, so let's use an x value of 0. All right, so when x is 0, if you plug 0 into right here, 0 minus 2 is negative 2. When you square that, you get 4. Plus 3 is 7. So 0, 7 is on the graph, which also means 4, 7 is going to be on the graph. And that would be our graph of the parabola. Okay. So just to review what we did, use the transformations, the 2 and the 3, use those transformations to figure out where your vertex is. And then pick some x values that are right around that vertex. Plug them into your equation and find out the corresponding y values and plot those points. Okay. All right, so let's look at the next one. This transformation right here is a shift to the left 4 units, and this is a shift up 6 units. So going left 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 puts us right up here. That is where your vertex is going to be located. Now we have a negative value right here in front of the parentheses, which tells us that the graph is going to be opening downward. Now the 1/2 is your a value. That has no number or no impact on where your vertex is located. Let me repeat that. Your a value will not have any impact on where the vertex of your parabola is located. The only thing that determines where the vertex is are your shifts to the left or right and up or down. Those are the only things that determine where your parabola vertex is going to be. All right, so we know that when x is negative 4, our vertex is right here. We need to pick some other points that are around negative 4. All right, so let's use an x value of negative 3. All right, so when x is negative 3, and you plug it in here, negative 3 plus 4 is 1. 1 squared is 1. Times negative 1/2 is negative 1/2. And negative 1/2 plus 6 is 5.5. All right, so negative 3 up 5.5 would put us about right there, which means the symmetrical point would be on the other side of the vertex. All right, let's pick another point. Let's use negative 2. All right, so when x is negative 2, negative 2 plus 4 is 2. When you square that, you get 4. 4 times negative 1/2 is negative 2. And then adding 6 to that gives you positive 4. All right, so negative 2, 4 is on the graph, which means the symmetrical point also is on the graph. And that will be a sketch of our parabola. Okay. All right, so let's move on to our actual systems here. All right, so on the first equation, this is our linear equation because the x has an exponent of 1. This will be our quadratic equation because it has a square on it. All right, so the linear equation, we need to solve for y. So I would subtract 2x to the other side, which will give you negative y equals negative 2x plus 3. Now we need to get rid of this negative right here, so we're going to divide by negative 1. That will make this a positive 2x and a minus 3. So graphing this, we start with the y-intercept, which is negative 3. So put a point at negative 3. Then we do our slope, which is 2. So we're going to rise 2 and run 1. So up 2 and to the right 1. Right, so plotting these points would put us along this line right here. All right, so let me draw the line here. All right, so the next thing we need to do is graph the parabola, which is this one. And once again, we need to solve for y. So we would take the 3, add it to the other side, which will give us negative 2, parenthesis, x minus 1 squared plus 3. This vertex will have a shift to the right 1 and up 3. So right 1 and up 3 puts us right here for the vertex. Now because there's a negative 2 right here, that tells us our parabola is going to be opening down because of the negative sign. So we already know when x is 1, our parabola is going to be at 3 for the vertex. We need to pick some points that are right around here, but we've already done the 1, so let's use 2. So when x is 2, you get 2 minus 1, which is 1. Squared is still 1. And 1 times negative 2 is negative 2. And negative 2 plus 3 is 1. So when x is 2, the y value is going to be negative 1, which is a point that is on that line. Since that point is on that line, that tells us that is going to be one of our intersection points. Now the symmetrical point is also on that graph, and it is on the other side of the vertex right there. All right, so let's now pick another point. Let's use an x value of 3. All right, so when x is 3, you have 3 minus 1 is 2. Squaring that gives you 4. 4 times negative 2 is negative 8. And negative 8 plus 3 is negative 5. So 3, 1, 2, 3, 4, 5 is right here. The symmetrical point is right here, which also is on our graph of the line. So sketching the curve, you're going to have a parabola that looks like this. And we have 2 intersection points. One is right here, and the other is right over here. Those 2 coordinates are 2, 1 and negative 1, negative 5. Therefore, those are the solutions to this problem. Remember that the numbers of a linear quadratic system, there may be 2 intersection points, as there are here. there could be one intersection point, or there could be no solutions to this. Okay. All right, and the next example here. Let's start out with our linear equation, which is this one. We need to solve for y, so that means y would equal negative 3x plus 4.5. Graphing that, we will start at the y-intercept of 4.5 and then go up 3 and to the right 1 for the slope. We can also go down 3 and to the left 1, and that point is also going to be on the line. All right, so sketching the line, it's going to look like this. Now let's work on the parabola. Well, the parabola is already in the form that we need it in. It's already solved for y. We have a shift to the right 3 units, and there is no vertical shift on this. So our parabola is just simply going to go to the right 3 units. Okay, so that's going to put us right over here. All right, so we need to pick some values that are close to this. All right, so let's use an x value of 2. Well, when x is 2, let's plug it in here. 2 minus 3 is negative 1. Squared is positive 1. Times a half is 1/2. So 2 comma 1/2 is on our graph, which means the symmetrical point on the other side of the vertex also is on the graph. Well, that doesn't give us enough information yet, so let's use an x value of 1. So 1 minus 3 is negative 2. Square that and you get 4. 4 times a half is 2. All right, so 1, 2 is on the graph, and so is the symmetrical point over here. Well, we have plotted our 5 points. However, we still don't know exactly where the intersection is, so let's find some more points. All right, so let's use an x value of 0 because that's getting closer to where the line is. So when the x value is 0, 0 minus 3 is negative 3, squared is positive 9, and 9 times a half is 4.5. Well, 0, 4.5, that point is on the line right here. And the symmetric point would be right over here. Well, this is a situation where your graph looks like it's going to have one solution. And that is actually the case. There is only one solution to this. This line will continue going up, but it is never going to intersect this curve over here.